You're actually having IT people, hardware people that actually now have to write more and more scripts to instantiate not just a server, but we're now at a place where you're instantiating entirely infrastructures. What would take you 6 months to an entire year if you want to spin up machines in Bangalore on your Nike can be done in a matter of hours using Terraform, right? Infrastructure is code. The infrastructure itself is programmatic. Let that sink in.
Hello and welcome to the Lewis and Kyle Show, an interview podcast where my friend Lewis and I interview super interesting people, whether that's crypto, real estate investing, entrepreneurs, CEOs, rappers, or anything in between there that Lewis and I think will be interesting, and we take what we learn and we share it with you all. Today, we have a really interesting guest on in Sheldon Gilbert.
Sheldon is the founder and CEO of the Proclivity Marketplace, which is a really awesome online system, one of the leading marketplaces for healthcare ads. He's a very strong data analyst guy, very good at using data to make predictions about what customers want in the ad space. In addition to that, in July of 2020, he launched a company, nonprofit, not a company, called Kura Labs. Kura is a completely free educational resource to help people get jobs in the growing field of need for internet architecture. That could be cloud computing, that could be blockchain engineering, that could be DevOps. He has really great free curriculum that helps people get jobs in that space. Prior to all of that, he did molecular bio at Yale, which gives him a really interesting insight onto these data companies since he's kind of approaching it with different mental models and people who's had a more traditional engineering path. And that really shows in this conversation. We cover a lot of the humanitarian use cases for blockchain to help the world, specifically underserved communities in ways like healthcare and in other unpredictable ways besides just the typical cryptocurrency narrative. We discuss the career opportunities in internet architecture that motivated him to create Kura Labs. And we also discuss and make some comparisons to the cryptocurrency blockchain trend to the big data trend of about 10 to 15 years ago, the genomics revolution that we're kind of in the middle of, and seeing what we can learn from the predictable phases of all of these big cycles. I'm excited for you to listen to this conversation, and I'm going to switch to it now. Enjoy. Sheldon, welcome to the Lewis and Kyle Show. Very excited to be chatting today.
Thanks, guys. Thanks for having me. Excited.
Of course. So my first question for you, unlike a lot of our guests, have a very specific thing that you're super eager to talk about, which makes our job as interviewers a lot easier. So we want to jump right into the meat and the excitement of what you have to say, and then let the conversation kind of fall apart and go in a million directions towards the 30-minute mark. So why is blockchain cryptocurrency important for underserved communities? Why is it important for them to understand that? How can it help them? What should we be doing to use this technology to help this group of people?
Yeah, well, I mean, there are a couple of things. One is, again, thanks for having me. It's a very broad topic, but I think that the premise, if you will, the vision, the promise of blockchain, when you actually, I'm sort of mapping back to the seminal paper by Satoshi and the pseudonym, right? So in 2008, 2009, let's really understand what was the premise for this. Is really the unraveling of the markets, the financial markets, 2008, 2009. And in the paper, he, they directly cited the sort of unmitigated abuse by a lot of central banking systems and central financing systems. And there's this notion of actually decentralizing the entire financial infrastructure. That was the premise. An idea that you could actually mitigate this abuse and make sure that everyone actually has an equal seat at the table. So effectively democratizing financial infrastructure. And that's been the central promise. The problem, though, and I do think that there's a broad promise around that. I think it's still very optimistic. But I think we have to be very mindful of the extent to which it seems that the barrier to entry is still quite high. When you actually consider you could participate certainly in actually being a node, let's say, on the entire distributed network for Bitcoin, for example. But if you were to actually mine coins, as you guys know, it's almost prohibitively expensive to actually have the infrastructure, particularly as we see it's getting exponentially more computationally rigorous to do so, given the entire premise of it being 21 million fixed units. And so the halving problem makes it exponentially more complicated to calculate. So to enter there, you actually have to have resources and capital. Even if you were to shift from a proof of work protocol to a proof of stake protocol, the barrier to entry there is still one of capital. I think you need to have at least 150,000, if not more, to actually have, particularly on Ether, to actually stake any of your coins or your assets to have him participate. And again, this locks out large populations of people and being able to sort of participate in that. That notwithstanding a lot of the sort of fairly complex and abstruse aspects of what these things really are and how they actually work. And there's a lot of opacity, which I think is available to some and not largely to the masses.
So I guess my question is like, why is democratizing financial infrastructure important? And two, why is it good for the everyday man, specifically underserved communities?
Well, let's just take something that's, I think, that in theory should have been fairly well democratized for a long time, is getting a loan, right? If you actually have the access to credit. So if you actually had the capital to support that and you actually have collateral to de-risk, getting a loan or getting a mortgage of some sort, one would imagine that those are fairly, let's say, I'd say fairly binary terms, quantitative terms that, you should be able to walk into a local bank and get that. In certain communities, certainly African-American communities, that has not been the case. There's been long-standing, policies around, redlining, or, where the first of all, a lot of people actually were being denied getting access to credit. Even if they were to get access to credit, in certain communities today, you still see sort of predatory terms on the financing terms. And so we see, again, there's been wanton abuse across the way. And so the idea now is that, imagine, if you will, that if I were to sort of strip away the human component, this is effectively what we're talking about here. I mean, when we talk about things like Bitcoin, if you take a giant step back, let's think about this. There's effectively a $2.5, nearly $3 trillion asset class that has sprung up in the last 11 years that is completely and entirely mediated by machines, okay? There's no human intervention whatsoever. It's outside the purview of any government, any NGO, any central authority. It's truly AI. And the brilliant aspect, which I'm sure we'll talk about later on, is how the network actually automatically recalibrates itself. The proof of work thresholds are automatically being recalibrated rather, I should say. So if you actually take this infrastructure, which is completely digitized, and we actually said these latent social biases should be stripped out of them. And so you could actually now imagine there being a smart contract that says if you actually have a certain salary and you actually have certain assets, you should be able to get a loan, regardless of your race, gender, age, and so forth. That is the promise of it being truly democratized. Now, again, doesn't mean that we can actually embed unconscious biases within the terms of the smart contracts themselves. But again, if the parameters of the smart contract are truly transparent, then all people should be able to detect those insidious aspects and stray away from those potentially problematic smart contracts. So again, it's the sort of opening up with a distributed and decentralized network. That makes any sense.
You also mentioned that it can, or I've seen you write about, you didn't bring it up yet, so people are like, what's he talking about? That it's also being used for healthcare in some important ways, blockchains, and the secure transfer of healthcare data to help like similar communities. What's that? Because that's actually something I'm completely unfamiliar with.
Yeah, I don't know to what extent it's actually being done right now. I think that certainly the sort of the promise of the way in which I think things I think the example you probably heard me talk about, or I probably had written about, is imagine a world. Someone sort of asked me, Sheldon, sort of talk about 5-6 years from now, what does the world start to look like? My background is in molecular genetics, so I deferred grad school in bioinformatics, computational genomics to start my company, Proclivity. So I think a lot about the genome and that primary code for nature. And one of the things that becomes important is this whole notion around what's called individualized medicine. And so the fact that we actually have all this telemetry now, we all have these systems that's actually measuring whether it's an Apple Watch or whatever it may be, or Fitbit, we actually have these sensors. And they're doing biometrics, and they're also doing telemetry. And imagine that information could actually be fed to the cloud, and there could be a certain smart contract that says if my heart rate goes at a certain level, then potentially I get certain medication that's actually being sent to me within a matter of 2 or 3 days. That's a sort of level of interconnectedness that we could actually have that could, in theory, be on a smart contract. This is sort of potentially where the world's going to eventually go.
That's extremely interesting, and you're going to like very high
and problematic,
levels.
Right?
Yeah, I want to go back to something though that about how, you know, redlining and like how impossible it is to get a loan and how impossible it was to get a loan as a black person in the 1960s, 1950s, and what that does to a community over over time. It has compounding negative effects on the community's ability to build wealth, right? And building wealth goes into so many different aspects of society and individuals' lives. And so when you say that smart contracts can actually democratize the credit markets for human beings, and it erases the subjectivity of a loan officer, I think that could have and will have massive, exponentially compounding positive effects on individual humans. And so I just want to point out that you did answer my question as to how is this helping people, specifically underserved communities, because it is a compounding negative effect when they can't get that credit.
Absolutely. And so it all has to do with the opacity, the extent to which these things are not transparent to people, these terms of all. And by the way, redlining and predatory terms are just one of many, many examples that African Americans and other disenfranchised communities have been faced with indigenous people, women, LGBTQ, Latinx. This is sort of, a function of long-standing aspects in this country and many other parts of the world. What I do think is important for us to highlight though is that we have to remember who's writing those smart contracts. They're still human beings with inherent biases. And so what I want to make sure is that it's not this 0.001% that actually understands solidity and could actually write these smart contracts. How do we actually democratize the writing of smart contracts as well? And that's one of the things I've also done in starting an academy that's focused on infrastructure computing and availing that as a career option for people from underserved communities, because I want to make sure that we're also involved in writing those smart contracts as well. It's, the authors of those terms, of those contracts are the ones who actually, as you mentioned before, this sort of force multiplier, that compounding effect, that's driven by the authors of those systems. And so I wanted to make sure that we're part of that discourse.
So how do you think, other than teaching people solidity, do you democratize the ability to understand and write smart contracts? Do you think that over a long enough time horizon, we just are speaking to a system and then it's programming it itself? Like, what do you think would be the most fair way to do it?
It's such a good question, and I think we're scratching the surface. I think it's known as smart contracts now. Who knows, in 10 years, we may be referring to something else. It could be called the grid, I'm not sure what form it's going to take. I think the rules remain the same, though. So, for example, let's talk about, a lot of systems actually have unintended secondary effects. So, as I've mentioned before to some friends, that one of my classmates from undergrad, Yale's actually on the board of Uber, was very much involved in Uber in the early stages. And I joked around with him and I said, thank you for bringing Uber to market, because now a lot of African Americans could actually now get taxi cabs. We could actually get cars now. Growing up in New York City, it was extraordinarily hard. I remember having my friends who were non-black having to hail a cab for me because they just wouldn't stop for us. They assumed that we couldn't pay or whatever it was. And that was always problematic and so forth. It's interesting, and the reason why I bring that up is that one of the intended aspects of Uber's algorithm in actually doing the matching, the real-time geo-based matching of passenger and driver, is that the driver was not ever shown the destination of the passenger, okay? And that was, I don't know how intentional that was, but it's certainly a secondary effect of that was making sure there was not sort of destination bias, okay? If in New York, if someone's going to, 85th Street and Madison Avenue versus somewhere in Brownsville, Brooklyn, the likelihood of actually the driver taking that ride is different, okay? And there's a sort of socio-political, racial calculus that's being done. And so, thankfully, the algorithm did not display that particular parameter, didn't ingest that parameter, and certainly didn't show it to the human being. it was certainly used to compute the real-time pricing in the market. But now, by the way, I think because of the sort of new labor-based laws in California, one of the things that's actually been done now is changing of that algorithm to actually now start to show the drivers, who will now be considered to be employees, the destinations. So again, the question is, it's an algorithm. Who wrote the algorithm? What are the secondary impacts of that? So going back to your broader question around it's not, smart contracts are just one modality. There could be many others. So if we think about participation in proof of stake based contracts, or staking your assets, and thresholds for proof of stake having $150,000, that becomes challenging. Or if you look at new liquidity pools like Uniswap 2.0, you could actually have individualized positions for your liquidity pool, your own sort of curve, your own yield curve, if you will. Does the gender of who's actually taking that position matter now for people who are contributing to the pool? Again, I think those biases could come into play as well. And so we have to think about how we design these systems. Oftentimes it's because people who actually do not have the capital can't make those trades. It's not even have to fall along racial lines or gender-based lines. It's people who actually don't have the liquidity can't really participate in the liquidity pool, right?
Well, I think one important thing that differentiates smart contracts from other forms where humans are the base layer, creating things that, create edge cases, that create large-scale human activity, like an Uber. Like one person at Uber does one button differently, and it affects a huge amount of things. For smart contracts, at least to my limited understanding, once you write it, once it is running, it is impossible to stop, right? That is a part of so these second order consequences that arise from humans being the base layer are impossible to stop, right?
Yeah, that's one of the limitations of smart contracts, to your point, exactly, Kyle, is that they're immutable. That's the entire premise, that they cannot be, they're tamper proof. And so it's
especially important that we get this right with
absolutely
smart contracts.
Absolutely. And you can't, they're irreversible. So the question is, there has to be extraordinary levels of diligence on the terms of those contracts. So they could be revoked if they have to be, but they can, because they are in fact immutable.
I have a question about proof of stake. This is kind of a very specific question, less big picture. What do you think about staking pools? Is that so for example, with a Coinbase account, you don't have to stake $150,000 worth of Ethereum to participate in some rewards. You can pool whatever amount of Ethereum you have, and then on their end, they make that an accumulated $150,000 from a group of people. Is that a partial solution? Things like, or even mining pools, for example, or does that take away some important decentralization?
Well, the question is, you're saying, how does one participate in the transaction fees, whether it's proof of stake or proof of work, using using these mining pools, participating in them? Potentially, yeah. I mean, you could actually imagine the three of us could actually decide to, raise some money, $300,000, and I think Kazakhstan now is the hot spot. I don't know if you guys saw, after particularly what's going on in China. So it happens to be Kazakhstan. I have a friend, one of my engineers at my company is actually from Uzbekistan. I was like, hey, whatever happened to Uzbekistan? So, but in any event, I think that you're seeing certainly the fractionalization of pool ownership could be an interesting play, certainly for people to participate in. I think it's definitely.
Is that a threat to decentralization, though?
I don't know how that's a threat to decentralization. If you recall, the idea is that everyone, it's first of all, the way this works is that it's both decentralized as well as distributed, right? They're two very different things. One could be decentralized and not be distributed. Distributed in particular means that everyone has a copy. So every single node on the network also has a copy of the data, of the ledger primarily. And what's important here is the arrival at decentralized consensus. That really is the game changer. that was probably the most seminal and brilliant aspect of Satoshi's development, is taking the blockchain and actually having machines independently arrive at consensus outside of human intervention by virtue of them all trying to solve a deterministic mathematical problem, which is having this nonce sequence, the sort of string of
zeros,
call it zeros right before at the beginning of the hash digest, which is extraordinarily difficult to do. So if you could arrive at that because it's deterministic, if you actually have the block, the entire sequential process of blocks plus the proof of work gives you that deterministic nonce. So it's decentralized. The question is, can you participate in becoming one of those verifiers in the decentralized network? Is a different story. It is going to be decentralized. That's why it's so interesting to see what happened with China. I had a friend of mine tell me years ago and said, Sheldon, is there a problem? Do you see a problem with China having 70% of the miners? I go, no, this is a dynamic organism. When you actually will sort of compress it here, it will then find its way elsewhere. It's a living organism. And so that's the power of it. The fact that it actually is now springing up, more and more coin miners are in Kazakhstan, is incredible. And there's more growth in the United States as well. But that decentralization and distribution. But it's I tell people all the time, the true innovation here is decentralized consensus. We're not putting that genie back in the bottle. I don't know 5 years from now if any of these coins are going to exist, but decentralized consensus is here to stay, and it's quite powerful. And that's going to change a lot of things, including medicine, amongst many other things, by the way, I think.
I'm going for my question. Because what you said right there at the end was, I don't know if any of these specific things are going to be here in 5 years. That creates a lot of perceived risk for people who already, don't have a shaky circumstance potentially to switch from, the US dollar system to locking up their assets or locking up whatever wealth they've been able to store over a period of time into this other system. So how do you get people or convince them or just approach the topic of risk in this context, or in the fact that, yes, it's more trustworthy based on decentralization and all the things you're bringing up from the technical perspective, but a lot of people don't perceive it that way. And even yourself have like a speech that is it still going to be here in the same way? So how do you approach the uncertainty of it being a brand new system?
Risk, you mean in terms of people taking positions, like saying, I'm taking, my grandmother's retirement account, half of it, and I'm actually trying to buy up lots of stable coins. Is that kind of, you mean sort of retail and market risk? What kind of risk are you referring to? I just want to make sure I understand.
Yeah. So if you're suggesting that, people from underserved communities participate in this ecosystem in the sense where instead of getting a loan from a bank, they're getting a loan from a DeFi protocol, and then that DeFi protocol ceases to exist and their whatever collateral disappears, things like this.
Yeah. So that's why I think, again, when I mentioned about not putting that genie back in the bottle, what you're going to start to see is taking the traditional institutions themselves now starting to adopt this technology. I'm sure you guys may have seen, for example, BNY Mellon and Goldman Sachs and JP Morgan. So the first ever repo trade was done. Goldman Sachs actually did a large repo trade on JP Morgan's Onyx.
What is a repo trade?
So repo trade, my understanding really around that is basically taking lots of, I think, treasuries, basically a lot of bonds, and actually, swapping and trading that. So, and apparently those things take a long time to settle. And so, it's apparently fairly analog. It takes a long time to settle. And this was actually done on a private blockchain, if you will, the Onyx private blockchain. Now, I have some friends who said this was really important PR for the traditional institutions to show that they too have crypto cred, right? Because if they're not careful, they will be disintermediated by these decentralized systems. So the point I'm making here is that you're taking these sort of decentralized systems and actually now institutionalizing it and bringing it and now privatizing it to a certain degree. And so that's what I think may end up happening is that there is inherent risk. Louis, the question you're asking there is really important because you're saying if you feel that there's going to be greater market access to capital under fairer terms or even more beneficial terms, at least for this particular window of time, where we actually are in the sort of frothy interest rate driven environment and so forth, low interest rates and so forth, you could actually get better terms on a DeFi network to get a loan. There are inherent risks to that across the board. And so, yes, that's why I think, again, I think right now we're still in very, very early stages. I think people need to understand those protocols. And listen, you're still collateralizing things. Doesn't mean that there's no collateral. You actually have to have crypto assets to collateralize to get the loan. And by the way, those assets, the prices are volatile. So you actually, it's like three-dimensional chess continuously. Everything's changing all the time. Now, you could, for a short period of time, get something, but there's inherent volatility. I think it will settle over time. And I think, for me, what's exciting is that these are new protocols. So from an engineering standpoint, a mathematical standpoint, it's fascinating. I think it's looking it's like the internet in 2000. We had a bunch of companies like Webvan and so forth that raised billions of dollars and went out in like 6 months. But the internet e-commerce was here to stay, right? That we're not putting that genie back in the bottle. Same thing here. I don't think we're putting decentralized consensus back in the bottle.
So decentralized consensus, you think it's going to touch a lot of different places, one being healthcare. Could you list a couple of other things like healthcare that you think that it'll impact dramatically, and then maybe we'll dive into one of them?
Yeah, I mean, I think about the fact that I want to be very clear when I say decentralized consensus. Like, first of all, what is consensus, right? Consensus is sort of establishing the truth, right? Sort of this unequivocal regard for a set of things that have occurred that we all agree, there's agreement, there's alignment that this is in fact what happened, okay? So that's consensus. And so the question is usually being human beings with a level of subjectivity, even with some empirical frameworks, could arrive at something everyone agrees. We have seen now in our institution, unfortunately, across the board, right now, we're at a seminal point right now in our country. There is no consensus on whether or not people should get vaccinated. That's profound. That's unheard of. That never happened before, right? When there was a vaccine, everyone went there. And now there is equivocation as to whether the efficacy of vaccines, whether or not the person who's residing at 1600 Pennsylvania Avenue was done so under legitimate terms. There's broad questioning of the polling and voting system. I mean, every single institution, the banking institution, even what we saw with trades, with Robinhood, the fact they actually halted trading because of that, that trade against all the hedge funds who actually had giant, call options or put options against that, and the trade being halted. Everything I have questions like, why was trading being halted there? Is this thing rigged, right? This whole notion of a central authority doing something that's fairly opaque and doesn't seem to be completely aligned with what everyone understood. So there's a questioning and so every instance where we see this questioning of the central authority lends itself naturally to people asking the question, well, if we were to decentralize this thing, will there be fairer transactions or transparent transactions? Now, obviously, we should always be thinking, once you have decentralized processes, there will be other costs there, one being latency, for example. There's always that trade-off. So I think of things, those are examples I was saying. I have to imagine we're going to see a decentralized voting mechanism in this country. I think we're going to start to see things like definitely like decentralized equity trading, right? There are a couple of already DEXs that are being created, decentralized exchanges being created as we speak, as we know. There's going to be decentralized, bond markets. We're going to start to see decentralized real estate brokerage. We're going to see decentralized commodity trading. We're going to start to see, in the case of medicine. So imagine this. Let's say I get an MRI scan, and I now, I'm using some sort of medical app, and it actually then takes that, actually uploads it into AWS, into some cloud provider. And the question is, do we actually have a bunch of machines that have extraordinary image recognition that could determine whether it's malignant versus benign tumor, or do I actually send it to my neuroradiologist or some radiologist, oncological radiologist, to determine that? One may argue at some point the machines may arrive at a better decision, a distributed network of machines may arrive at a better decision than a trained human physician. That's the machines arriving at consensus, right, on my health fate of my life, right? So I think you're going to see forms of that across the board.
I also think that you're just getting some wheels turning in my head with like, some COVID disagreement about, or not disagreement, but no lack of of consensus on the truth with things like vaccines, things like a claim I've heard on a lot of podcasts is that, PCR testing has had a high false positive rate or something like that.
That's right.
So if you
the rapid test,
so if you put the PCR results on the blockchain with some anonymized data about, a couple other health markers that would indicate in the weeks following whether or not it was or was not a false positive, and then people can kind of make their own conclusions from like whatever that Oracle service was.
That's
and
exactly
same thing
it.
with the vaccines, right? If
That's
people
exactly
are concerned about the vaccine causing heart issues, but then you have anonymized Apple Watch heart data put on the blockchain for every vaccine recipient, it's like people can actually verify that this is the true percentage in which this actually had any deviation.
That's exactly it. I mean, and if we were to even take it at an even crazier level, imagine we get to a place, this is going back to my molecular bio days, but you actually basically having everyone's gene expression and their proteomic expression and their metabolomic expression all being captured through some sort of microarray, and having that tokenized and having that instantiated on the blockchain and saying every single quanta, every single instance is there. You could actually see people's immune profile, their immune response, and saying this in fact did happen. This is someone's physiological, genomic, if you will, token. We may have to go to that place.
So that true cause and effect can't be lied about.
Right.
That makes a lot of sense.
Right.
That's very.
I mean, this is potentially where things could go.
That's Epology getting on a podcast sharing that idea because of his bio background as well.
So I know very little about genomics, but I want to ask a question. This might be totally wrong, but we've seen the graphs of the cost of sequencing a genome going down exponentially for the last 20 years, and I feel like for as long as I could remember, people have talked about how that was going to change the world, and now that it is very cheap to do so, I don't feel like I'm seeing it change my world. And so is that coming really soon? Is it right around the corner? What is it in general, I guess?
It's hard to say, when or how exactly it's going to materialize in itself to you in ways that's going to be very clear. But let's kind of walk through a couple of steps on this thing. So there's a difference between, you want to think about this as basically three main layers. There's the genomic layer, which is basically, we take, Kyle, we could look at all of your cells and we actually see what the genetic sequence is, right? Okay. And the genes basically are the sort of array of chemical base pairs, and the way you want to think, and by the way, what's really interesting, by the way, is that there's actually more genetic variability within races than there are between races, which is a very interesting thing to think about, by the way, because actually really sort of stands in the face and the calls into question the sort of whole social construct of race. Race is a social construct. It's a socio-political construct to sort of justify certain economic actions. Whole other podcast, but so we could look at so when you think of the genome, I want you to think of you've got these sort of genes that are there, and each gene has to express something. It's the output of the gene. So you basically have this code, and we could actually have ACCCTG, right? And let's say that code's for, I don't know, brown eyes, okay? If you change one letter in that, and so it'll create these genes that then code for brown eyes. So you have the genomic layer that gets translated to outputs of the genes that are being read are proteins, and then proteins govern all aspects of our lives. It's our hormones, it's our chemical signaling, it's all neurotransmitters, everything. And so the proteins working together control our entire body at what's called a metabolomic layer. So you go from the genomic layer to the proteomic layer to the metabolomic layer, okay? We're still at the genomic layer. We're still trying to, we basically, when I graduated from college was 1997. So, long time ago when dinosaurs are still roaming Central Park. So, that's when the human genome had just been mapped. And the promise of that, by the way, is saying, let us understand all the letters. Once we understand all the letters, then we could actually understand what proteins are then created. Understanding the interaction of proteins is extraordinarily complicated. And I think once you actually have things like, quantum computing is going to really speed it up, because you're actually going the interaction of genes, one level of complexity, then the interaction of proteins, whole other level of complexity. Then all those proteins and all those larger systems interact with each other at the metabolomic layer. So how do you go from the genes here, blue eyes, or change one sequence in that could actually now lead to Alzheimer's? Like that downstream cascading effect of Alzheimer's is extraordinarily complicated to map out, right? And we're nowhere near that yet. We're still at the genomic layer. Now, here's something to pay attention to, this whole notion of CRISPR. You guys heard of the CRISPR complex? Right? This is fascinating. That means that scientists now with a level of precision could go in there and literally edit genes. They could literally edit genes now. That's a level of precision that we have at the genomic scale to go in there, target a particular sequence, and if we do see that could actually potentially map to pancreatic cancer, go in there and correct that and reverse it, right? It's like it's spell check for the genome at that level of precision. That's remarkable. That's opening a whole other revolution. And I think CRISPR was just basically discovered and developed about 6 years ago. So that's a massive race there. That's a whole other level of development and innovation is going to come out of that. And which is going to, and there's a very thin line that separates gene therapy from gene enhancement. So we have to be very mindful about all the laws around that.
I have another question about similarities and differences. We didn't cover your background too much. We'll, of course, have said it in the introduction. But you have obviously this very sophisticated biology background. But then when you're coming out of college, you kind of perceive the data revolution coming around you and chose to use just all the opportunities emerging from that space to build your career and build a business. And it seems like you're seeing similar opportunities, except now you're kind of focusing a lot more on humanitarian implications as well. What would you describe as the kind of cyclic similarities and differences? You said earlier this kind of like the internet in the 2000s in terms of crypto adoption. Are there opportunities to start companies? Are the main things served? Where are like the opportunities in this space? Where are we, as you see it, in kind of the life cycle?
Yeah, it's interesting. So I would say that the two things for me that have been really important, so if I will have served as my North Star when I think about a lot of things. One is I'm always trying to understand what is the fundamental problem that we're solving. The problem right now with a lot of things, crypto, is that they're solutions looking for problems. Okay, for the most part, it's sort of highly esoteric, and these liquidity pools, automated liquidity pools. Do we really need them? I mean, not sure. I mean, if we take a giant step back, one of the things that's really interesting to think about is that we are dealing with a time due largely to COVID, where we're going to be dealing with unprecedented economic dislocation, food insecurity, housing insecurity, career insecurity, and what we've seen with the gig economy the promise has not been unleashed. What we've seen is basically a compression of long-term wages and so forth, right? So we're dealing with true scarcity. On the other side of that, simultaneously, we actually have people who are trying to now go and colonize Mars, or creating synthetic scarcity, NFTs, all these cryptocurrencies. We are truly trying to create value. And so at least my view on this is that why is this even happening? Why? I think it has a lot to do with, it has little to do with the technology. It's follow the money, understand the economic factors, right? The golden rule, he or she who owns the gold makes the rules. So why is this occurring? Well, I think, this is my view, I'm happy to hear other people what they have to think. We basically have a sustained long period of effectively zero interest rates. So you have people who, wealth that's been staying in banks is basically generating no yield. You're now shifting it into other asset classes where there is yield. The reason why the stock market's been on a tear has little to do with the fundamental economics of the vast majority of companies, is because that's where the capital is going, okay? The other place the capital is going are these crypto assets. It's Bitcoin. Why? In many ways, one could say it was first supposed to be a currency. It's not. It's more of a store of value. We've all heard that before. Effectively acting as gold as a hedge against inflation, although that has not been playing itself out, over a short period of time, but eventually it could be. It's where one's going to maximize yield. So interest rates are very, very low in the standard bank finance system. You actually move to other asset class where there's high yield. Once interest rates go back up, we'll see. Let's see what happens to the NFTs of the world and all these different things. It may actually get pulled. The capital may actually get pulled out. What I do think is here to stay is the decentralized consensus and apply to other things outside of cryptocurrencies and the financial institution per se. I think some aspects will be appended, but it's really understanding where capital is being deployed. So I always try and understand the macro factors. Why are these things? What's the fundamental problem that we're solving? I don't think NFTs are solving a fundamental problem. They're trying to create, if the problem, I don't know how fundamental it is how does one ensure scarcity? I have a Tom Brady NFL, rookie card, Topps card. Okay, I have that. Well, when I digitize it, which ironically the premise of the computer was to actually create copies of things in a very effective manner. So I'm actually now trying to create scarcity in a digital landscape. I mean, is that a truly practical problem for us to be solving? I don't think so. I think for some wealthy people who want to put their money behind certain things, it becomes interesting. But, I don't think it's a fundamental problem. Now, that said, my second axiom I always look at is, again, during the gold rush, who made money? The ones who sold shovels and pickaxes, right? And so if you look at the companies that have actually established, any value during this crypto craze, it's the ones who are selling the shovels and pickaxes. It's the intermediaries for the trading. It's Coinbase, right? It's Uniswap, Balancer. They're just marketplaces. Binance, they're just marketplaces because they're not taking positions. There's no Goldman in crypto. If anything, it's me, Golden, who's taking positions. Like, no one's taking massive positions in crypto. It's too volatile. But what you are, there are a lot of people who are making money off of that entropy, off that volatility. So if I were to do something, I'm saying, how do I, there are a few things I could do. Either I provide the analytics to help people make their trades, or I become the mechanism for trading. That's where I usually think opportunities are for scale, is becoming the marketplace. Uber's a marketplace. Airbnb, marketplace. OpenTable, marketplace. StubHub, Google, marketplace. These are all marketplaces.
So what was the fundamental problem that you were trying to solve when you founded Proclivity?
Fundamental problem that I was trying to solve with Proclivity was there was a lot of unstructured data. And I started Proclivity some time ago, back in around, so I deferred grad school like around, as I mentioned, so I had a background in genomics and was interested, and I taught myself the program, and I learned about algorithms. And I said, wait, what if I could combine my interest in genomics with algorithms, go to grad school for bioinformatics? And a friend said, grad school is always going to be there, start this idea. And the idea was, I was working at a number of e-commerce companies. They had all this data, massive amounts of, but mostly unstructured data. And back then, the idea was, how do you take all this unstructured data and actually now integrate that into a highly structured environment, like a relational database? Okay? Typically back then, most things in data warehouse were done in an OLAP database. A data warehouse was done usually Oracle, some relational database schema. And once you load all that data in, then you could basically run all these algorithms, right? Naive Bayesian algorithms, non-naive genetic algorithms, neural networks. The problem is that stuff didn't really work. The reason why it didn't work is two things. Taking that unstructured data and making it structured was extraordinarily difficult. And then running these algorithms on massive amounts of, when I say unstructured data, like clickstream data weblog data was very unstructured, very, very high volume. And to run a non-naive Bayesian network on that, on 5 years worth of data, the answers are never coming back. So I saw this as an opportunity. I said, how do I actually take data that's unstructured and then structure it as I'm loading it in my ETL process and then running algorithms at the same time and actually was borrowing aspects I was seeing done in the genomic world, because the data structure was changing all the time, because you had genes being discovered, so the schema kept on changing, and that's called EAV modeling. So, which basically started to open up this whole notion of this sort of whole NoSQL data structure movement, unstructured databases and so forth. And I sort of filed some patents around, mining unstructured data. And that became the premise for Proclivity. And the fundamental problem we were solving was people really had a lot of e-commerce companies had no effective way of trying to look at someone's unstructured website behavior and predicting what they're going to buy, when, and what price. So using that data to create a very fast algorithm was the problem, and that's what we were solving in the first instantiation of Proclivity. Now we've since extended that to become an electronic marketplace. No surprise. I told you guys, become the marketplace. That's what we've now morphed to become in a different area. Hopefully that all made sense. Right?
Definitely. I have a question. It might fumble a couple pieces here, but so half kind of the internet's been classified into some phases like Web 1, Web 2, Web 2 being marketplaces like Uber and Airbnb, Web 1 being basic hypertext and pages with maybe some images, and kind of Web 3 is blockchains. Then also on the same data thing, it's kind of the semantic web, the read-write web, graph databases. What do you think about that half of the Web 3 movement based on your background in data, the graph databases and some of the same challenges with, computational inefficiency of kind of coming to computers having implicit meaning of the data?
Yeah, it's funny you asked that question, because that's actually one of the seminal areas of genomics, really, is this whole notion of what's called ontological modeling and class labeling, which are classic algorithmic problems, which is once you actually have an ontology of data, how do you actually define that? Is this related to the pancreas, or is this related to the cerebellum? What are we talking about here? How do you actually classify data and label it? And that has oftentimes been a human exercise, a human activity. And imagine now you actually having, what would it be like to have machines start doing that labeling, that ontological modeling, and maybe in a arriving at through a decentralized consensus mechanism. That becomes interesting too, right? So I think that is, it's interesting, Lewis, you sort of mentioned the sort of iterations. I had another friend explain the internet, if you will, to me in different stages, which I thought was fascinating. So around in the 1990s, the entry point for information was really a portal. You had AOL, you had Yahoo, the browser was the portal, right? Then after that, how did people find information? Was not through a portal, was now through
search,
right? Google, right? Yahoo, AskGees, right? Bing, and so forth, right? Was search. Then Facebook came along, and the entry point for information was your social graph. It was not through search. In fact, most companies became companies by virtue of building the business on top of Google, like Zappos, for example. Zappos, most companies, you didn't exist unless you were on. Facebook was the first company that actually built itself completely outside of Google's paradigm, right? So you went from portal to search engine to social graph, right? And then now people are saying, well, the fundamental plumbing is now changing now into, you had decentralized file system was effectively the internet. Now we have decentralized databases, right? And distributed databases is the new framework. And arriving at consensus is now decentralized, which is the new thing.
So your company, I don't know how to pronounce it. Kura, how do you say that?
Oh, so it's a nonprofit I started called Kura Labs. Kura means to grow in Swahili.
Oh, interesting. So that is designed to help people learn how to build the plumbing of this next phase of the internet. Can you get into that for a little bit?
That's a good way of thinking about it. So basically,
and the goal's $1 billion in wages. I just wanted to throw that in there. I saw that the goal's $1 billion in wages.
Yeah, so exactly. So basically, Kuro was born out of a real problem that my team and I were experiencing. So with Proclivity, we actually we felt at least we were fairly early in terms of adopting cloud and adopting AWS. I want to say back in 2013, 2014 or some time ago, right? So we're pretty early. And once we actually migrated from on-prem, or effectively by using off of our data centers and so forth, and moving into the cloud, I immediately saw the writing on the wall. I said, wait a second, time out. We're talking about on-demand computing, on-demand storage. So I'm effectively taking, if you look at someone's P&L, the finance department's doing cartwheels down the street, because you're now going from fixed operating expenses, that's fixed by having a data center, you got a rent rack space, you actually have an IT team, everyone's provisioning, everyone's managing, you got to license machines. There's a certain cost that's fixed, to now having that being COGS, a cost of goods sold, entirely variable. You only pay as you go. It's effectively I call the fractional economy. It's the same thing what Uber's done for transportation. You only pay when you need it. Airbnb, you only pay when you need it. It's what cloud computing did, right? So you only pay as you go. And so what I also saw was that there was going to be this emergence of this new, what I call a hybrid type of engineer. It's not just a software engineer, and you don't really have pure IT hardware engineers anymore, because all being provisioned by these cloud providers. They are now going to remotely control and configure the machines remotely. So you're actually having IT people, hardware people, that actually now have to write more and more scripts to instantiate not just a server, but we're now at a place where you're instantiating entirely infrastructures. What would take you 6 months to an entire year, if you want to spin up machines in Bangalore on your Nike, can be done in a matter of hours using Terraform, right? Infrastructure is code. The infrastructure itself is programmatic, right? Let that sink in. You could spin up entire infrastructures in hours around the world. It's fascinating. So this called for a new type of engineer. And so way back when we were trying to hire these engineers, the joke I always like to say, which is true, which is it took us almost 18 to 24 months, Kyle and Lewis, that we got so desperate, so exasperated. If you could spell AWS, we just threw money at you and said, we'll train you. And so I realized, fast forwarding, particularly around what we saw with regards to the George Floyd protests, and listen, I tell people all the time, I was not remotely surprised by what happened to George Floyd. In many communities, this is what happens all the time. The only difference is that we now actually have, this to establish decentralized consensus, right? Is the cameras, right? And so everyone's protesting. I'm protesting too. But I also knew that this is a matter of economic inclusion, economic equality. And so I realized that what if I were to create a vocational academy for the 21st century, and this is not focused around software engineering. That train's already left the station. These companies are not hiring, engineers out of Detroit or East Palo Alto or South Central LA or the South Bronx, right? There are plenty of people with PhDs out of Shenzhen and Kiev and Bangalore. What's important here is now it's the infrastructure is the new code construct. And so what if I were to create an academy that's focused entirely on that? There's such a massive workforce imbalance. There's far more demand for these engineers, call them DevOps engineers, SRE, Cloud Ops, Data Ops, SecOps. There's so much demand for these engineers. They simply do not exist. All these companies are clamoring for these engineers. So I was lucky enough to go talk to some people, CEO of NASDAQ, Adina Friedman, several others, and explain to them what we're going to be training our students in a short period of time. It's entirely free. She's like, listen, you had me at Kubernetes. I get it. We're all in. And so in a matter of about 6 to 8 months, we were able to we raised some capital from a couple of nonprofits. Thankful for them. And we basically all online. We hired instructors, gave them free training to our students. And right after the program, the vast majority, about nearly over 80% of them actually all got jobs at high tier companies, JP Morgan Chase, NASDAQ, Oracle, my company Proclivity, Mocafy, several others. With starting salaries like $90,000. You have to understand they're coming from households where the average combined household income is $35,000. So overnight, students are making more than twice the combined salary of their parents. It is ejecting them out of poverty. And the idea here is that there's extraordinary demand for this. So as we hear the Biden administration talk about the infrastructure plan, this is part of the infrastructure. It's also the digital infrastructure, right?
Is this an ongoing thing, or are you doing it in cohorts? Is the training free to anyone who wants to sign up? How did you gate the content?
Yes, so the training is entirely free. We started in New York. It is now national, and we are going to also make it international. We do have some students from the Caribbean as well who are also getting free training here. And it's also designed to be self-sufficient. So we do have donors, but most companies are more than happy to sort of pay a nominal placement fee for the hiring of our graduates. Two reasons: one, they need these engineers, but two, they come from underserved communities, and these companies are clamoring for that level of diverse talent. They recognize it's a human rights issue, it's an economic issue quite frankly, and so we're meeting those two critical needs there. So it actually has a lot of high scale. The curriculum is all proprietary. We designed the curriculum, and we touch on a number of critical points. So it's now 6 months. Everything from Linux to Python to networking to server configuration, virtualization, containerization, infrastructure as code. Focused a lot on the CI/CD pipeline, but also we actually added a new track here per our conversation there's a track here on smart contracts. So not only will our students learn how to deploy centralized applications, but also decentralized applications too. AWS actually has an integration into Ethereum Solidity compiler. So that's one of the things too that our students will actually be learning. But it's all thinking about an infrastructure, or application development, whether it's centralized or decentralized. Those two modalities are important.
Sounds like an incredible thing that you're doing.
Thank you.
That sounds awesome. Wow. I mean, jobs are just so important.
Mm-hmm. Absolutely. Long-term careers.
About everything that we're talking about, jobs are central to them.
Yeah.
So I think we'll transition to our what we call our bonus round, which is just a little off-topic, few questions for you.
Yeah.
What do you do every day? What is your everyday life like? Your bioinformatics, biochemistry, Proclivity, marketing, starting nonprofits. It's like, what does your average day look like?
Well, I say I'm still just curious about on the bioinformatics side. I left the lab, so many in academia would say, I'm no longer part of the crew because I traded my lab coat for a couch in Silicon Valley about 20 years ago. But it's still a primary love and interest of mine. It's actually how I think about a lot of problems in the world. But I love learning, and it never stops. So I guess how do I think? So I'm a dad, and so that's my North Star. My daughter, and I used to be a night owl. I would stay up till 2, 3 in the morning and find valor in that, which is ridiculous, by the way. I now wake up in the morning pretty early, about 6 o'clock in the morning, 5, 6 o'clock in the morning. I would stay awake. I would never. The only time I'd ever see that 7 o'clock was when I was younger. I just stay up that late. But now I wake up early. I'm 20 times more productive, and so now I focus a lot on areas of productivity. So on staff we have yoga instructors, we have meditation instructors, we also have a core fitness trainer. That it's really important to actually get those endorphins coursing through, right? It's emotionally it's better for you. You actually do clearer thinking. So I organize my day around. I wake up early. I'm reading a number of different things, international news, the sort of things around finance and tech and politics and science. And so it's my early morning reading. I'll then may go for I may do a workout here and there, and then I start having meetings with my teams, and I have over time. Early on, I was not really good at delegating. That's an art, and I was forced to do so when I became a dad because I had no choice. And so it actually forced us to get really clear on who we want in our company who could actually take the job and run with it. One of the things I've actually learned is I don't manage people, I manage processes, and that's an axiom I've actually held. And so that's really served us well. We have a no blame culture. We don't blame people. If there's a problem, typically it's a breakdown in communication processes. So we focus really on trying to refine our processes as much as we can. And so I focus a lot on our internal algorithm for getting things built, deployed, run, scaling, pricing, and so forth.
Different question. Do you personally make any data-informed decisions? Just so not using data to buy efficient ads and predict what people want to buy, but do you track any personal metrics and change the way you act based on any personal data analysis?
In terms of personal data, So you mean like, for example, because if I'm working out or I'm going for a run, do I actually have like a heart rate monitor, things of that nature? You mean is that what you're referring to? Do I make decisions around that?
Well, I was just wondering if like you have any data collection. We're all collecting data about ourselves all the time without realizing it, or use a time tracker system or anything like this. Like, it seems like you're a very data-informed decision maker. So I was wondering if that applies to your personal life as well.
It's interesting, when it comes to my personal life, no, I actually try and leave room for sort of that other, enigmatic decisioning engine, which is called the hunch. I try a lot to try and process things, thinking about the chessboard and saying, if we were to do this, how would this arise? How will this impact people? How do we actually convince the customer to understand these things? How do we engender trust? How do we take these complex ideas and actually distill them in a way that makes it available to them? And that has little to do with data. It has everything to do with psychodynamics and being attuned to those things. In that regard, I try and go a lot on how I feel when I wake up in the morning with a lot of things. There's some data on the edges. Sometimes you think about that, but for the most part, I go on I guess the best word for it, there's no scientific word, call one's hunch and one's instinct, but I try to be very reflective on that. Perfect example, by the way, was Kura. So, right, like I didn't have a lot of data on Kura. I just knew I had some macro sense, but I remember when we got started, we had no money. I said, it doesn't matter, we'll figure it out. The money will come. I was telling this to the other co-founders. I said, this will come. They're like, are you sure? I'm like, trust me, this will happen. And that's just a feeling, and you kind of will it into action.
Yeah, I think it's important to listen to that. And I think that if you only listen to data, if you only try and track like blood glucose levels, and it's like eventually, you've got to fall back on what's human.
Right.
And I think one thing that's just as human as any other thing that I've ever observed is the way that your face lit up when you started talking about your child.
Right.
I don't know if it was a girl or boy.
It's a girl.
What is it genetically that happens? I mean, I guess it's all our DNA is for is to create another human.
Right.
That's like our main processor function.
Yeah.
But do you have any? So this is a very human thing. But do you have any data, or is there a scientific process that you can talk about in genetics or genomics around having children and the way that parents feel about children?
Yeah. So, wow, that's quite the question there, Kyle. So, the two ways I could think about this. One is that one could argue that we are basically wired to procreate, right? That's our purpose in life in a very clinical, biological, primal way. We're just engines to create more life and so forth. And the species continues. And I'll answer that in two ways. One is earlier today, in fact, my daughter was 9. She asked me about, Daddy, what is puberty, right? We're kind of talking about those different things. And I was explaining to her, I said, it is the phase in which adolescents actually now are ready to, their reproductive organs start to form, and they actually have the ability to now start having children. And she's like, wow, 13, 14, 12, that's really young. I said, well, in every species, the reproductive age is always half of the natural lifespan of every species. Our natural lifespan is really 26 to 30 years old. It's because of modern medicine, in particular the advent of penicillin in particular, that our lifespan is now 80, 90 years old. But our natural lifespan is really 30 years old. And the question is, and here's the point, we live long enough so that our progeny arrives at their own reproductive age. And then we could actually die off. The hyenas could actually claim us on the Serengeti, but our child is now old enough. So if I have my child at, let's say, 13, 14, and if I live to 26 or to 30, my child is now 13, 14. So if I get killed by the hyenas and claimed by them, my child is now old enough. I've protected my child so that the species could continue. That is a very deep wiring, I believe. That's the reason why I brought it up. Like our lifespan is actually tethered to the reproductive age of our children. That's how deeply, wired, that is. I'm sure the book's written about this called The Selfish Gene. I think in very ways we're sort of just wired to protect. If you look at nature, why is it that in very, very brutal ways it gets played out? Again, going back to the Serengeti, you'll see that once a male lion takes over pride, one of the first things that the male lion does, it actually will infanticide. It will kill all the cubs, right? Of the one that he actually vanquished the other lion, and then all the female lions automatically go into estrus. They will start to the reproductive organs now start to be ready to be. I feel like we're on some nature show now, right? But they now get ready. So it's interesting what happens is because that creature is designed to now procreate, right? That procreation. Now, how that gets manifested emotionally, the emotional registry is a function of our genome and our proteome and our metabolome, right? How that gets wired through a series of hormones, a number of different things.
That's definitely why we advertise. That's why we start with the stuff to stay on topic at the beginning. So otherwise, it's like, you can start with the important stuff and then you have fun.
Well, this is the important
stuff. That's also very true. That's very true.
Yeah.
It determines how long you live, so that's very important. I think we're wrapping up on time here. I want to ask you if we covered a lot of ground, so helping underserved communities with blockchain, economic opportunities in just cloud computing infrastructure in general and in crypto. What are the resources you'd recommend for people to go either to contribute to the causes that help underserved communities, learn about the economic opportunities for themselves, the resources you've created, or anywhere else people should go and learn about your work?
Yeah, I think there's a lot of work that's going out there, a lot of programs, not just ours. There are programs like Perscolas and Empower. These are workforce training programs. I think Google also now has a free certification program. There are lots of programs out there, a lot of resources online, Coursera, Udemy, remarkable programs. And I recommend everyone, access them. Sometimes it's not, I don't think it's sufficient. I don't think you're going to get a job by actually just going on Coursera and learning these things, because the problem is that when you're going for an interview, it's one thing to actually understand what Kubernetes is theoretically. It's another thing to say, I've actually done 5 deployments using Kubernetes or Ansible or Jenkins and so forth, right? And so it's having that experience, which is really important, that companies are looking for. And so that's the benefit of academies like this, is that we actually give you that hands-on functional training, because we all know we don't learn things until we break them. It's not until you struggle do you really understand how to solve the problem. And so they need those reps, right? It's the same with if you go to a vocational school, you become an electrician, you need to actually have built enough circuitry to understand it and so forth. So that's what our focus is on. So the tons of assets that are out there. YouTube is great. Khan Academy is fantastic. If I could leave you with one thing about this interesting thing about the ledger and Bitcoin and so forth. So reparations is a hot topic, as you could imagine, and so forth. And one of the things I thought has always been fascinating, people say things like, the problem is it's likely a very intractable problem. We can't solve that. How do we actually trace back? And we understand it was the original sin and so forth. I go, listen, if we could actually invent Bitcoin and we could actually launch people up in Mars, I'm sure we could solve that problem. But that aside, it's interesting. So people always said, well, it's really hard to actually get evidence for that. I'll point you to one very interesting thing. Georgetown University was Jesuit, founded by Jesuits and so forth. And at some point, it turns out that they were actually becoming insolvent. And they were going bankrupt, losing money. And they actually have a notebook, a ledger, that showed that they actually had slaves and actually sold those slaves to someone in Louisiana. And that actually, they actually were able to now maintain the university. And to this day, they have a massive $1 billion endowment and so forth. Were it not for this trade that's in a ledger, right? And I just think it's really, and so there's an interesting idea, like, that's on the blockchain. It's not on the digital blockchain, but that's on this analog blockchain. What would it be like, right? Because people have been saying, well, we're not sure what really happened and so forth. Were it not for this ledger transaction, it's interesting how this ledger is playing itself out. And so I just think, again, it's fascinating to see these things sort of play out. We're dealing with these larger socio-political things that oftentimes come down to economics, and people saying, well, it's hard to prove that. Well, that's just one example. How many other transactions, millions of them that took place, that led to tens of billions of dollars, that will never be appropriated to certain people. I mean, we had reparations in this country for Native Americans, for Japanese during internment, for Jewish individuals in Europe as well as here in the United States, not for African Americans. So I just think it's a very interesting thing, given the economic calculus involved and this existence of this transaction and many other transactions that are on these ledgers, right?
So you're suggesting the coming technologies will be helpful in like reconciling this issue?
I don't think they're going to reconcile them. I just think it's fascinating.
I think it's
this whole notion of the ledger. Yeah.
Mm-hmm.
I think it's more about like what it's going to be like in the future. Like, the bad things are happening today, and in the future, when we need to do something like reparations, we will have a blockchain.
Right. Yeah. Exactly. In other words, were it not for these records that were kept in this university, right, in their stacks, in their libraries, that is the original ledger. Right, and what would it be like to now like NFT those pages? Right, that becomes an interesting thing. That's what I'm saying. Well, yeah.
That makes sense.
What will it be like?
What will it be like?
The eventuality that we are headed toward.
Mm-hmm.
Sheldon, we really appreciate it, and thank you for sharing your time and for all of your wisdom. That was a really wide-ranging and interesting conversation. We really enjoyed it.
Yeah, I enjoyed it, guys. Really, thanks again, and I appreciate what you're doing. This is great.
Thank you.
Thank you.
And that wraps up our conversation with Sheldon. Very interesting guy. I've got 3 quick takeaways. The one big thing that he was really trying to drive into us was just the idea of distributed consensus and how important that is and how important it will be to the future. I think that he sees it outside of just for cryptocurrencies and sees its applications in his own fields like healthcare. And it's going to have really large impacts on those industries in the form of creating something that everybody can agree on. And once they agree on it, it is immutable. There's no debate as to whether or not they agreed on it in that period of time. And so I think that a future with that will be much different than a future without it, or past without having distributed consensus. So I'm excited to see that happen. The next is the credit markets and how basically blockchain allows for completely trustless, permissionless lending, and just how access to those credit markets in the past has been such a determinant of whether or not people were able to build wealth, and what that has done for communities and what it will do for communities to not have any sort of constraint on your ability to get loan dollars based on your skin color. And obviously that's a good thing. Obviously a future with that is bright. And then that makes me think about like somewhere like India, where they don't have, I don't know whether or not they have traditional finance systems or how built up they are, but I imagine that it's probably not as easy to get a loan on a piece of real estate, let's say, than it is in America. And this protocol, or this imagined protocol, would be available globally. And so it could really do a lot of things for a lot of people. And then my third takeaway is something that Lewis mentioned in the intro, which is just how he looks at life through a different lens than normal because of his background in genomics, and how having had such a different variable background from what other people have, he has all these mental models that other people who studied business or science, they have their own mental models, but genomics specifically allows him to look at the world in this really interesting way that sort of shows through how he explains things in this podcast. Those are my takeaways. I thought he was a super interesting and smart person, and I was happy to talk with him.
Yeah, I completely agree. I'm very glad that we had the opportunity to meet and shoot the breeze with Sheldon. Agreed, very smart. 3 takeaways from me. First one, the same as yours. He repeated it more than anything else because it was by far the most important point he wanted to get across. Distributed consensus is the big possibility of blockchain. So the way I've kind of realized he's deconstructing these topics is he's breaking down what the new technology makes possible that was previously not possible. And based on those raw potentials, he kind of imagines the use cases. And the real important raw potential here is distributed consensus, meaning, again, like you said, there's a group of people that don't trust each other, don't necessarily even know who each other are, but they can agree on something because there's an immutable ledger that's cryptographically proven. It would almost be, it's fundamentally impossible for it to not be true if this distributed consensus system works. And the past 10 years of Bitcoin working as a way for people to facilitate transactions without knowing who the other person is and without trusting them has proven that this model can work. And now he's discussing other applications. I think the two most interesting he brought up were voting and vaccines. So blockchain voting, the big reason we need distributed consensus is so we can trust something like an election. If we don't have faith in the system, or if there's a large majority of people who don't have trust in the system, that's really problematic. But if there's a blockchain that proves beyond any reasonable doubt, because it's just cryptographically true, that these are the votes that were cast, then that problem and all of the controversy that comes from disagreement goes away. And the same can be said for vaccine. You put the records on the blockchain of who got the shot and what their health consequences were, and you can't argue about these statistics because the blockchain proves that they're true. So that's really, really exciting. Second takeaway for me would be positioning in the marketplace. So he kind of made the analogy, you've heard it many times before, I'm sure if you're in a gold rush, you want to be selling shovels, not digging for gold. The importance of that is you want to be making money and you want to be able to feed your family whether or not any gold is found. Whether or not the price of Bitcoin goes up or down, you're making money because you're getting a transaction fee. So finding some way to, whether or not this takes off, you're still the person that built the architecture, they still have to pay you. So if you're in the marketplace as one of those people, then you're going to be positioned to be a lot better regardless of what happens. And I think that's a very good place to be and a good thing to keep in mind. Third takeaway were some of Sheldon's attitudes towards culture in his companies. One, he called it a no-blame environment. I really like that. I think blaming people is kind of assuming bad intentions or assuming stupidity, when in reality, maybe just the instructions, the process wasn't clear enough. So the focus on addressing processes and systematizing your business makes it less of a headache for everyone because they're not all mad at each other. And you actually now have really good processes and can work more smoothly, hire people more easily, things like that. The other big thing in his culture of Kura Labs was project-based learning, so learning by doing. I think that's always a healthy reminder. We talk to a lot of people on here that do a lot of courses and a lot of teaching, and it's pretty much the theme with all of them is doing it through projects, doing it through real scenarios is the way to actually learn, apply, and remember. That's all I have to say about this episode with Sheldon. I'm really grateful to you and to Sheldon for listening, Sheldon for coming on the podcast, Kyle for being my co-host, all of the people. If you enjoy this and want more from us, we've posted a lot of content. I'm not sure how many people out there have listened to every single episode, so get started. We've got another 77 episodes or so in the feed. Scroll down, listen to another one, leave a review if you've been listening and enjoying this and have not already. That would be very, very helpful. We are behind on reviews. We've been keeping pace where we have a review for every episode we have, and now we're at episode 78, and we're only at about 76 reviews, so you got to get us back on track. That can be you. Thanks so much for doing that if you do. Otherwise, we'll be back in a couple weeks with the next episode. We have some travel coming up and might be a little behind on the publishing, but we'll be back soon. Thanks so much for listening. See you then. Bye-bye.